Have you ever wondered how AI really knows things? How it can nail the capital of France one second, but then confidently invent a totally fake historical event the next? Well, today, we're pulling back the curtain on its secret brain. We're talking about a hidden structure that separates fact from fiction, the very thing that's going to make AI truly trustworthy. We're talking about knowledge graphs, and trust me, they're about to change everything you think you know about artificial intelligence.
Look, we're in this weird, fascinating moment with AI, right? On one hand, what it can do is just exploding. It can whip up stunning art from a few words, write complex code in seconds, and even compose music that feels, well, human. But for all that power, it has this one huge flaw. It just makes stuff up. You've probably heard the term hallucination. That's when an AI serves up pure fiction as if it's gospel truth. And this isn't just some minor bug, it's a really deep issue that makes you stop and ask, how can we possibly build our future on these amazing tools if they can't even tell what's real?
And this is so much bigger than just a funny chatbot mistake. I mean, imagine you're a bank using AI to manage risk. A hallucinated number could trigger a total disaster. Or think about healthcare, where an AI might suggest a drug interaction based on data it just invented. In these fields, you have zero room for creative facts. The thing is, generative AI is fantastic at predicting the next word in a sentence, which is why it sounds so convincing. But it doesn't actually understand the world in a structured, factual way. So how do we give it a backbone of truth? Well, that's where our story really begins.
To fix this, we can't just throw more books at the AI. We need to give it a map of facts that's structured, verifiable, and shows how everything connects. The answer is something called a knowledge graph. And it's less like a messy library of books and more like an incredibly detailed, interconnected mind map, but one that's built specifically for a machine to read. This is the tech that provides the factual grounding AI so desperately needs to go from being a creative toy to a tool we can actually rely on.
So what is a knowledge graph, really? Let's break it right down. At its heart, it's a really simple, elegant idea. It's a network built out of two basic things. First, you have entities. You can just think of these as the nodes or the nouns on our map: a person, a company, a movie, a city. And second, you have the relationships. These are the edges or the verbs that connect them. Directed by, is located in, works for. By linking these nodes with these edges, you start to build this powerful, structured map of real-world facts that a computer can actually understand and reason with.
This quote just nails it. If you've ever drawn a mind map for a project, drawing bubbles for your ideas and then connecting them with lines to show how they relate, then you already get the basic idea. A knowledge graph is just that, but on a massive, planetary scale for, well, everything. It's not just storing the fact that Paris exists and France exists. It's storing the unbreakable, explicit connection that Paris is the capital of France. It's this web of proven connections that gives a machine real understanding.
Okay, so we've got the big idea. It's a mind map for machines. But how does it actually get built? What are the nuts and bolts that let it connect all those millions or even billions of dots into a picture of the world that actually makes sense? Let's pop the hood and look at the three simple components that make it all tick.
Seriously, it all comes down to these three parts. Let's use an example. First up, the nodes, the things. So, we create a node for the person Christopher Nolan and another one for the movie The Dark Knight. Right now, they're just two separate dots. Second, we add the edges, the relationships. We draw a line between them, and we label it with the verb directed by. Boom. Now we have a fact. Christopher Nolan, directed by The Dark Knight. And finally, we add properties, the little details that matter. On the Dark Knight node, we can add a property like release date 2008. Using just these three things, you can map out incredibly complex information in a way that's simple, clean, and perfectly readable for a machine. Now, to really get why knowledge graphs are such a big deal, it helps to see where they fit in with all the other AI buzzwords. You've probably heard of vector search. It's amazing at finding things that are just similar in meaning, like finding other sci-fi movies if you liked Inception. Then you've got RAG, which is great at just grabbing relevant paragraphs from a huge pile of documents. But the knowledge graph, it's playing a totally different game. Its superpower isn't finding stuff that's similar or fetching text, it's understanding the explicit, logical relationships between things. That's what lets an AI actually reason.
I absolutely love this metaphor because it makes the difference crystal clear. A vector search is kind of like a tour guide that says, "Oh, you like the Empire State Building? Cool. Here are 5 other tall Art Deco skyscrapers." It's useful, sure, but it's kind of limited. A knowledge graph, on the other hand, is like a full-on city map combined with a history book. It doesn't just show you the other buildings, it shows you the roads connecting them, who the architect was, what other buildings they designed, what materials they used. It sees the whole interconnected system, the roads, the history, the context, not just the individual buildings.
Now, here's the really cool part. This isn't some futuristic sci-fi tech. You are already using knowledge graphs every single day, and you probably don't even realize it. They are the invisible engine humming away behind the scenes of some of the biggest websites and apps in the world. So let's take a look at how they're already powering the tech you use constantly.
You know when you search for a celebrity or a movie and you get that slick info box on the side of the page? The one with their birthday, key facts, related people, all that stuff? That is Google's knowledge graph, right there. When you type Eiffel Tower, Google doesn't just see 2 words. Its graph knows you're asking about a specific thing in the real world. So it pulls structured facts right from its map. Eiffel Tower is located in Paris. Eiffel Tower was designed by Gustave Eiffel. It's giving you facts, not just a list of blue links.
This very same logic is the secret sauce behind all those amazing recommendation engines. When Netflix suggests a new show for you, it's doing way more than just matching keywords. Its knowledge graph knows that Christopher Nolan directed The Dark Knight, which shares the gritty thriller genre with The Batman, which also happens to star actors who are in other movies you liked. It's this rich, tangled web of relationships that lets it make those spooky, how did they know I'd love this suggestions. It's all about context.
And this is where things get really serious. In the business world, the stakes are incredibly high. Take fraud detection. A criminal might try to hide their tracks using a complex web of shell companies and dozens of small transactions. To a normal system, those just look like random noise. But a knowledge graph connects the dots. It can see that account A sent money to account B, which is owned by someone who's on the board of a company that also owns account C. You see? The graph reveals the hidden network. In industries where one mistake can cost millions, or even lives, you can't have an AI that's just guessing. You need one that knows. And that's why knowledge graphs are so essential.
So, this all brings us to the big picture. We've talked about what knowledge graphs are, how they work, and where you're already using them. But why are they becoming so incredibly important right now? What does this all mean for the next generation of AI and really for all of us?
It really boils down to 3 huge things we're now demanding from our AI. First, and this is the big one, factual grounding. We just have to stop these systems from making stuff up, period. Second, we need explainability. Industries like finance and medicine can't run on a black box that just spits out answers. They need to see the receipts. A knowledge graph lets you trace the exact facts that led to a conclusion. And third, the really exciting part, is logical reasoning. If we want AI agents that can actually plan and make smart decisions in the real world, giving them a factual map of that world isn't just a nice to have, it's absolutely essential.
And this gets us to what might be the single most important takeaway here. The future of AI is not a fight between different technologies. It's not large language models versus knowledge graphs. That's just the wrong way to think about it. The real magic, the breakthrough moment, happens when you combine their strengths, when you create a hybrid system where each part makes the others way more powerful.
This right here is the winning formula for the next chapter of AI. Think of it like assembling an expert team. The knowledge graph is your senior expert with 30 years of experience. It holds all the verified structured facts. RAG is the super smart research assistant who knows exactly which page of the expert's brain to open for any question. And the large language model, that's your charismatic, eloquent spokesperson who can take that precise information and communicate it to you perfectly. Put them all together and you get an AI that's not just smart, but also reliable, explainable, and trustworthy.
So I'll leave you with this. For the last few years, we've all been amazed by what AI can creatively generate. But once you ground it with a backbone of actual truth, the focus shifts to the massive, world-changing problems it can reliably solve. Imagine an AI that doesn't just guess how a protein might fold, but can explain the exact chain of events that makes it happen, supercharging drug discovery. Imagine an AI that can design a city's power grid with 0 points of failure because it understands every single dependency. That's the future that a foundation of verifiable truth makes possible.